right. So, hi everyone, I'm Talia. I'm actually not a senior developer advocate at AWS anymore. I recently joined Akamai as a lead developer advocate. And so today we're going to be talking about building applications with infrastructure as code. Very excited to be in Porto. This is my second time in Porto. And it's funny because when I landed, I could already tell who's American and who's European because it's freezing outside, it's raining, and the Americans are bundled up in jackets and sweaters, and the Europeans are in t-shirts, nothing happened, it's normal weather. So again, my name's Talia. I'm a lead developer advocate for Akamai, and what I do is I basically create content about everything that has to do with cloud computing and Linode, and then I talk and write about the content that I create. So my job is just to build things in the cloud and then teach the world about them. Before becoming a dev advocate, I was a test engineer, so I did automation, QA, end-to-end testing, everything that you developers hate doing. That was my job. Before Akamai, I was at a small cloud computing company called AWS. I was on the serverless team there. All right, so in this talk, we're going to go through an intro to infrastructure as code. And if you haven't used infrastructure as code or you don't know what it is, don't worry. We're going to go through it. We're going to go through use cases. We're going to talk about some of the benefits. And then we're going to talk about Linode and Terraform. And those are the two tools that I kind of walk through in the presentation. And then we'll do a quick demo. And I'll show you how to set up your own infrastructure. All right, so many times when developers first start building in the cloud, you're brand new to the cloud, you want to build something in the cloud, you start in your cloud console, right? You choose the services you want, and then you create them, and you connect them together, right? So you build your Lambda function here, you build your database here, you build your and anything you want. You build your server, you build something else here, and then you have to go into the console and connect them, right? So chances are you're not going to be able to recreate everything you just did, right? But the great thing about using the console is that you have this UI that shows you what you have in your application, and it's a visual representation of what's existing inside of your application, right? And the only problem comes when you want to move your resources to different accounts. Maybe you want to move everything to a test account or to a test environment. Maybe you want to replicate something that you've done. How do you do that? How do you move all of the resources exactly with all of those configurations to a different place? Move it to one environment to another, or just recreate everything that you've done. So chances are you're not going to know exactly how you set up those resources, exactly how you set up that infrastructure, right? So to solve this problem, we're going to look outside of the console to something called infrastructure as code. So with infrastructure as code, you're automating that provisioning process, right? So that means you're not going to go to the console, click on the services you want, configure and create the resources you want from the console. You're going to create something that's called a configuration file. And this configuration file is where you're going to define all of the resources that you want and all of the configurations for those resources. And this is how you instantiate your infrastructure. Now, what's great about this is that this acts as one source of truth. This configuration file, you have one place with all the steps for your configurations, all the steps for your resources, and you can access it whenever you need. And what this does is it allows you to treat your infrastructure as your infrastructure and your configuration files as code. And what do you do with code? You version it, you put it in some kind of repo, you put it in GitHub or Bitbucket or whatever it is. So then you can deploy a version, work on it, and merge a new version. But the great thing is that if something goes wrong, you can just roll it back to a different state. And this is a great way to make changes to your infrastructure securely because you know that you're treating your infrastructure the same way that you're treating code. So again, if something breaks, well, you can just roll it back to a different version, move it to a different environment, or push through a new version. So basically, you have this flexibility to build, change, and manage your infrastructure in a safe, consistent, and repeatable way. So why is this important, right? Why is building infrastructure with code better than building in the UI? By using the same configuration files, you're ensuring consistency between environments. And this takes care of that, well, hey, it works on my machine shenanigans, right? Like when I was a test engineer, you don't know how many times I would test something, I would find a bug, and then the developer would be like, oh, well, it works on my machine, what are you talking about? So this is one way to ensure that consistency between your environments. You have one source of truth that is this configuration file. It's also great for onboarding developers. So when you're onboarding a new developer and they're setting up their environment and like someone comes and they give them this huge book of like, okay, this is how you set up your environment, and they go through like everything and they're like sitting in the corner crying because they don't know what they're doing, versus you give them a configuration file, you're like, deploy this, that's your environment, done. And it's a great way to just speed up that process, speed up that onboarding, and everyone's happy. Another benefit to infrastructure as code is that it eliminates configuration drift. And so what this is let's say you get paged one night because there's an incident for your mobile application, like something's wrong with your mobile application, and you get paged. You have to figure out what's going on. So you figure out what the problem is, and the problem is it's a configuration that's in production. So you make the configuration change in production, and then you go back to sleep because it's like the middle of the night. So even though you fixed the issue, you've just created an even bigger divide between your staging and production environments because you didn't make the same change in your staging environment. So a lot of times your environments, your test environments and your production environment, they're not the same because of changes made during incident management, and this is called configuration drift. So with infrastructure as code, rather than having configuration drift, you have this one central authority, that's this configuration file. You make the changes in that configuration file, and then you push the infrastructure changes through. It also decreases risk. So provisioning all of your infrastructure by hand is really risky. Like if you go into the console, create all your infrastructure there, do all the configuration changes there, it's really risky because the person who's doing it, they're the one person who knows everything about the infrastructure. Like what if they leave the company? What if they didn't document everything correctly, you know? There's a lot of risk involved in that. But here you're saying you have reproducible blocks of code that are your infrastructure, and they live in a source code repository, and all of the history and changes are visible to the team. So you're really decreasing a lot of your risk when you use infrastructure as code. Okay, so how do we actually implement infrastructure as code? We're going to talk about two tools today. One of them is called Linode. It's a cloud computing platform. The other one is called Terraform. Terraform is an infrastructure as code tool that you can use for defining both cloud and on-prem resources. And we're going to go through a demo at the end that uses both of these tools together. But first, I kind of want to talk about Terraform and Linode together. So the way that you use infrastructure as code, like I said before, is something that's called configuration files. And so your configuration files are declarative, meaning they describe the end state of your infrastructure. So you're saying, this is what I want my infrastructure to look like. I want this resource with these configurations. I want this other resource with these configurations. And you don't have to say how to make them. Like, you know, in the console, you have to click on this, and then you have to go do this and click on those configurations and set this specific capacity. Like, no, you're going to one place, you're setting all the configurations. You don't have to write instructions of how to create them because Terraform understands that underlying logic. And all you're doing is you're describing the overall topology. And so when you deploy this configuration file, these resources are either going to be created or updated depending on the current state. If they exist, they're just going to be updated. If they don't exist, they're going to be created. And so in this example configuration file, we're saying, hello, please create this IAM role with these configurations, and please create this Lambda function with these configurations. Thank you, have a nice day, that's it. So I don't have to tell Terraform how to do this. Terraform is a smart cookie. It's going to handle all that logic to create or update the resources that are in your configuration file. All right, so there's a specific workflow that you have to follow when you use Terraform, and it's very intuitive. And so there's 3 different commands that we're going to go through. The first thing you need to do is a little obvious. You have to write your configuration file. And again, this is where you define the resources that you want to create. All the elements that you need is in this configuration file. And there's a command called Terraform Refresh. And so what Terraform Refresh does is it goes out, it's going to talk to all of the cloud providers that you've connected, AWS, Google, Linode. It's going to talk to everyone and say, what's the current state? Like, what's currently running right now? So if there's already, databases running, if there's already servers running, if there's already Lambda functions running, it's going to get that current state from whatever providers, and it's going to say, okay, I have the current state when you run Terraform Refresh. Next, Terraform creates an execution plan, and this is where Terraform says, this is where it figures out, what do I need to do to get to that desired state? So the configuration file, that's like your desired state. That's what you want to happen, right? That's your end goal. And so Terraform says, okay, you want to create these resources, you want this network from GCP, or you want this database on AWS, or this virtual instance on Linode. What you define in your configuration file, that's your desired state. And then when you run Terraform plan, Terraform says, okay, this is the plan to get to that desired state. And then we have Terraform apply. And Terraform apply is where you actually perform the operations that are proposed, and it actually goes ahead and executes the plan. It figures out what the correct order is to create all the resources, and it goes ahead and executes that plan. Okay, there's a couple of parts to Terraform that are pretty essential to the way that it works. The first is Terraform core. Core is responsible for a few things. First, it takes in that configuration file. It takes in that file that we just created with all the resources. It also takes in the current state, and this is what it gets when you run Terraform Refresh. It's that source of truth for your environment. And then it uses the state file to determine what changes does your infrastructure need to make to match that configuration. And then just to note, you'll see this in the demo, but normally Terraform state files or Terraform configuration files are in a .tf state file. You can also use just like a .tf file, and that's how Terraform knows that that's what it needs to talk to. Okay, so then core is responsible for figuring out how do the different pieces of the infrastructure relate to each other, how do they talk to each other, what needs to be created, what needs to be updated. It's responsible for all of the lifecycle management. And then on the back side, you have providers. And providers can be a few different things. We have things like infrastructure as a service tools like AWS, Azure, GCP, and Linode. They could be on-prem infrastructure like VMware. They could be platform as a service tools like Heroku, Kubernetes. They could be software as a service tools like Splunk or GitHub. There's a lot of things that you have in your infrastructure. You have things like source control like GitHub. You have monitoring with things like Splunk. And these are all externally managed, right? So these are all tools that are not managed within Terraform, but Terraform understands that everything is connected, right? So you have all of these important pieces of infrastructure, and you can't deliver your application without the infrastructure as a service, the platform as a service, and the software as a service. They're all part of your logical end-to-end delivery. And so when you use infrastructure as code, when you use Terraform, you get the single unified delivery of all of your components, right? So you don't want to have to use one tool for your monitoring, one tooling for your infrastructure, one tool for your observability, one tool for every component and every service that you add to your application. You don't have to piece together all of these things. Instead, you have one tool that's going to piece everything together for you. You have this API, and you have this lifecycle management that's associated with it. And then Terraform can enable them as a provider to create an end-to-end solution. Okay, when you adopt infrastructure as code, a lot of times either you already have infrastructure created or you don't really know where to start. So we're going to talk a little bit about adopting infrastructure as code. And so the first way to do this is as someone starting brand new, someone with no existing infrastructure, basically someone starting from day one. So on day one, you go from running nothing to running something. And so this is where you provision your initial set of infrastructure, and you describe what's your desired configuration. And then when you run Terraform refresh says, hey, there's nothing there. I just need to create all these resources for you. And then you create your plan, and plan creates an execution plan. And then apply goes out and either creates or updates things for you. Then there's the more challenging day 2 plus, and this is where you have your existing set of infrastructure and you're evolving it. So your infrastructure is going to change over time, right? It's going to increase in complexity one day, it's going to decrease in complexity the next day. It's constantly evolving. You're adding new services, you're removing services, you change configurations. So you have this existing infrastructure and you can enhance it by adding resources, you can decrease the complexity by removing resources. So when you run Terraform refresh, Terraform will say, hey, you know what, you need to add these new elements to get to your desired configuration, and then when you run apply, those new resources are going to look like the desired state. So this is great because over time, you're going to change your infrastructure. It's going to evolve, and you have this process that's going to take care of all of that management for you. And then on day N, this could be sometime in the future, you can decommission your infrastructure. And so maybe these resources were for a test environment, or for some reason you don't need that infrastructure anymore. You can run Terraform destroy, and this is going to destroy all the resources that are in your configuration file. And it's basically just like a specialized version of apply where it creates a special destroy plan. So there's a lot of advantages to this workflow, and the great part about using infrastructure as code is that your day 1 experience is identical to day 2. So you have this workflow of creating, updating, deleting resources, and it doesn't change as your company, as your team grows, right? Like you have this methodology that's in place, and it's something that you're going to keep doing. Your infrastructure is going to be constantly evolving. You have this one source of truth, and it's going to keep changing, evolving, adding complexity, removing complexity. But the great thing is that you don't need separate processes for each stage of development. Another advantage is on day N, when you decide you have to decommission this environment, or you decide you don't need this infrastructure anymore, you have this built-in way to remove resources, and it's just a way to clean up your environment. And so in this life cycle, you go from having nothing to something, you evolve it, and then you decommission it. So as your team grows, it can be challenging to manage your infrastructure. And so normally companies will start with like a single person. This is like very common in startups especially, like a single DevOps person, like you're responsible for the infrastructure, and they're using infrastructure as code locally, right? And so their workflow will start with one single person who's running Terraform plan. And plan tells them, all right, what does this configuration do? And this specific person knows everything about the infrastructure because they wrote it, right? They wrote that configuration file. But now, what happens when you go from a single individual to a growing team? Let's say your infrastructure is evolving, your team's evolving, you have more resources, you have more things to do. So what do you do? So other people here want to collaborate on managing the same infrastructure, but you want to make sure that you're not stepping on each other's toes, right? You don't want to make changes in parallel that are going to overlap each other. So there's something called Terraform Enterprise, and this with this workflow, it augments the previous workflow a little bit. All you're doing now is you're adding version control. So you use GitHub or Bitbucket, and you move all of your configuration files into a central repository where you're managing and coordinating all of the changes. And so in this way, you keep track of all of your infrastructure as code changes, so you know what happened in the past, you know the changes that are being made. And so you have this state file that has like the current state of your application, and you manage it centrally, which is really important when you're using infrastructure as code. Okay, so now your company's doing really well, and maybe you have different teams that are using infrastructure as code. It's not just one team, it's a group of people. So something that you can do is create this thing called modules. And modules are like a black box of infrastructure where, maybe Joe Schmo, he doesn't need to know about every single part of your infrastructure. He doesn't need to know all the specifics about how to create this specific database or how to create this part of your application. He just needs to be able to spin that up when he needs to. So you can create something called a module where all you have to do is say, create this thing from the UI, and then Joe can go click on that and it's created for them. So it's kind of like a black box of infrastructure where there's going to be certain people who don't need to know about every detail of your infrastructure, and it acts like a container for multiple resources. Okay, so how do we manage and share all of these modules? There is a central repository, and it's a registry that exists. So there's a global public registry right now, and the website is registry.terraform.io, and you can go and you can find common infrastructure patterns, you can find common architectural patterns. Many of these are published by the cloud providers themselves. So like, for example, AWS will go and say, hey, this is how you create a Lambda function, and there'll be a chunk of code, and it'll say, this is a Lambda function, these are standard configurations, copy and paste this into your configuration file. It's a really great way to learn and build if you haven't used infrastructure as code yet. Okay, now you might be thinking to yourself, Talia, that's great, and I want to use Terraform, but I already have existing infrastructure that wasn't built on Terraform. So what do I do? So the answer is that you can import your existing infrastructure. And so what you have to do is, there's basically 5 steps. First, you identify the existing infrastructure that you have to import. And then you import the infrastructure into your Terraform state. And then you have to write the configuration file that matches that infrastructure. And then you review the Terraform plan, and then you apply the configuration to update your Terraform state. So it's kind of the same as what you have originally, what we talked about originally, except you just have to create a configuration file that matches what your current state is. So another benefit of using infrastructure as code is that you can do something called multi-cloud deployment. So I think it's very rare that companies and teams only use one cloud provider. Does anyone here use more than one cloud provider? Raise your hand. Okay, now raise your hand if you only use one cloud provider. Really? That's interesting. Okay, so I think multi-cloud is growing, and so infrastructure as code is one way that you can use different cloud providers. Okay, so let's recap the advantages of Terraform, and specifically the advantages of using infrastructure as code. First, it enables everyone, regardless of your DevOps experience, to be able to self-service their infrastructure, right? So you can implement the principle of least privilege and use modules for people who don't necessarily need access for all of the physical details of the infrastructure. You also get this natural progression from day 1 to day 2 to day n, and from single person to a team to many people in an entire organization. When you use infrastructure as code, you have a single unified delivery of of everything, and it gives you just a holistic view of what's going on in your application. You can also import your existing infrastructure, and you can do multi-cloud deployments. Okay, so we're going to use the Linode Terraform provider. So Linode is an infrastructure as a service tool, and there is a Linode provider that Terraform is connected with. So I'm going to post this tutorial link at the end of the presentation so you can access it, so you don't have to copy all of this down. But I just want to show you kind of how easy it is to create resources with infrastructure as code. So the first step, the first thing we have to do is generate SSH keys. And for those of you who haven't used SSH, it's like the best way to connect to servers. It's like a very trusted way to connect and administer your servers. This is kind of what the connection looks like. You have the secure connection between your client and your server, and there's two common forms of traditional authentication. You have passwords and an SSH key. So passwords you can just set from the console, but for SSH key authentication, you have a private key and a public key, and you have to generate a public key because you need to add that to your configuration file. Okay, some of the use cases for SSH, the most important one is to just remotely access everything that's happening in a server. You can transfer files between computers over a network. You can remotely execute commands. But the most important thing to remember with SSH is this is how you connect to your server. This is how you talk to your server. So to generate your SSH keys, there's this command called SSH keygen. There's something at the end, -B4096. It's the number of bits to use when generating the key pair, and it's just like a recommended security thing. And then you get this message that says, okay, we're going to create this key pair for you. Then you choose where to save it and create a passphrase. So with your keys generated, you have to copy the public key to the root user's SSH directory that's on the Linode instance, so it can be used to authenticate. So to do this, you use the SSH copy ID command. And so now you have this secure connection, and you can continue to use Terraform. So next, you need to create a Linode API token. And this is easy. You just go to the Linode UI, choose API tokens from the profile drop-down menu, and then choose Create a Personal Access Token. You can choose your access levels, what kind of access do you want to give, and then save it locally so you can access it easily, because you won't be able to retrieve this later from the console. Then you install Terraform, and then you create a project directory called Terraform and navigate to it. Verify Terraform can run by just running the command Terraform. And you can see this is a list of like all the different commands that are available. Okay, now this is the fun part. You're going to build with the Linode provider. So we need to create your configuration file and save it in a .tf file. That's how Terraform knows what to look at. And so the easiest way to do this, I think you can also do this from like, VS Code and create a new file, do it that way. But you can also just do nano and then the name of the file, .tf. And again, this is your configuration file. This is where you define all of the resources that you want. Here, I'm creating a Linode instance, and I'm calling it Terraform Web Example. You need to add your Linode API token. You have to add your public SSH key and the root password that you created. Okay, now we need to initialize Terraform by running Terraform init. Then you run Terraform plan. It creates the execution plan. It's going to look at the configuration file and say, okay, you want to create this instance, and these are the configurations you set. And that you're telling Terraform, I want to create these specific resources and these configurations. Then you run Terraform apply. It's going to go ahead and create, in this case, we created a resource. We created a Linode instance. And so now when you go to the UI, you can see the Terraform Web Example was created for you. So the first time you do this, there's a lot of setup. You have to set up your API token. You have to create your SSH key. But I hope you can see that the process of editing your configuration file and deploying a new configuration file, it's a relatively easy process. And so what's great is that you have a repository of resources that you can put into your configuration file, and those are already created for you. So it's just a great way to have one source of truth, everything in one place, and it's a very repeatable process. So if you want to go through an entire demo of using infrastructure as code, building with Linode and Terraform, this is the link to do that. There's also a ton of learning resources on the Linode YouTube channel. We also have a DevOps community. Terraform is an open source project that you can contribute to. And I think, yep, that's all I have. Thank you. Thank you. I'm happy to answer questions if anybody has a question. I think we'll get to you next.
Let me see.
Okay. Hey, Tassi, thanks for the presentation. I wanted to understand a bit better whether you see this sort of tools like Terraform and others as such as sort of antagonists to others like the serverless framework, or do you see them as sort of complementary, right?
Yeah. Okay, so serverless is it's a different way of creating resources, right? Like with serverless, you don't have to deal with managing your servers. You don't have to deal with it's pay-as-you-go pricing, so you don't have to. You only pay for the resources that you use. It's a different way of building, and I think serverless is great for like scalability. If you need your application to scale really big and really fast, and you don't want to deal with servers, and you don't want to deal with pricing and all of that, then I think serverless would be a good option for you. But a lot of times your company doesn't need to have such big scaling, or you don't need to have pay-as-you-go pricing, or you don't need to have built-in availability and fault tolerance. Like it just depends on your business needs. But I would, from my experience, coming from the serverless side, it depends on your business needs. So yeah, I think a lot of times you don't need all of that.
Yes, you don't. But just to kind of elaborate a bit better on the question, I didn't mean like serverless as in the concept, but more like the serverless framework is sort of an abstraction on top of serverless. Like you can provision the functions, DynamoDB, things like that, and you can actually provision things with IAC. There's sort of a YML file where you provision things. But it gets to a point where you can no longer do it. Like you cannot provision DNS records, for example. So it gets to a certain stage where you can no longer provision more things. And I wanted to understand whether you feel like you should just completely ditch that side of things and move everything completely to Terraform, or you feel like you could somehow complement and then eventually phase into something like Terraform.
Yeah, so the great thing about Terraform is that you can use both serverless and non-serverless resources. So, from the beginning, if you're building something that has, a server or an instance or whatever it is, and it's not specifically serverless, you can start building it in Terraform. But to the point where what you're talking about, to the point where like you need to stop and transfer everything over from serverless framework. I've never used serverless framework. I came from AWS serverless, and we used a tool called SAM, the SAM framework.
SAM, yeah,
right. So in that case, I would just build everything on SAM that's serverless. But you can also use a tool in AWS called CloudFormation. And with CloudFormation, it's also an infrastructure as code tool where you can use both serverless and non-serverless resources. So in your case, I would say just move everything from SAM to CloudFormation, and that way you have both in the same place.
Great, thank you.
I think there was a question here.
Thanks. It was very informative. I have a question about the level of control you have over the resources. Let's say I'm trying to use Terraform to set up a testing environment, and I'm creating a bucket, on an S3 bucket.
Okay.
And to run tests, I want to populate that bucket with assets, and maybe I'm setting up a database that I also want to populate. Is it possible to import those assets to the bucket through Terraform and populate the database? or would that have to be a separate process?
So I would suggest using a SaaS testing tool. Like, there's what was the big one that I like? Robot Framework is what I have used and recommend. So like, if you can integrate that with Terraform, run your tests with that, and then you can use the resources that are in your infrastructure as code file.
Okay. So that tool would automate the database creation.
No, so the database creation goes from Terraform, but the tests will run from this service provider.
What about the assets on the database? So
You mean when the test is running?
like the tables on the database? Can I import some table with configurations to run the tests?
Yeah, you do that in your configuration file.
Okay, thanks.
Okay, thank you, everybody.